Hi folks, we're going to take a look at the solutions for questions 3 and 4 from the Unit 6 Quiz 2. We'll start with question 3 here. We have a quadratic function that passes through these 3 points and we want to determine the equation. Now these points are given explicitly. They could also be given in a graph, in a table of values, or even on a diagram. So first thing we have to do is figure out which form of the equation we should work with. So if I had one of the x-intercepts, I would work with factored form. If I had either the h or k value of the vertex or the whole vertex, I would work with vertex form. In this case here, I notice that 0, 4 is the y-intercept. So I'm going to choose to work with standard form since that shows the y-intercept explicitly. So we have y equals ax squared plus bx plus c, standard form, and we remember that the c value is the y-intercept. So right off the bat, I can use one of my pieces of information to determine the c value. Okay, I now have the a and b unknowns that I still have to determine, and we're going to do what we normally do when we've got two unknowns, is we're going to create a system of equations. So here I'm going to use the other 2 points to create 2 equations that I can solve to determine a and b. So we'll start with negative 2, 18, and put that into the equation. So y is equal to 18. A times x is negative 2 squared. Remember to put the brackets around the input. Plus b times negative 2 plus 4. And let's simplify that. So 18 equals, this gives us positive 4a. This will be minus 2b plus 4. Okay, I'm going to put the variables on the left-hand side. So I'll have 4a minus 2b. And I needed to bring the plus 4 to the other side. So 18 minus 4 is 14. Okay, we'll call that equation 1. Now we'll do the same thing with the point 3, 13. Stick that in the equation. So y is equal to 13. A times 3 squared plus b times 3 plus 4. Notice how I put the input in brackets. Even though it is positive, won't make a difference. I just try to keep that going so I never forget to do it. So here we've got 13 equals 9a plus 3b plus 4. And again, let's rearrange 9a plus 3b, and 13 minus 4 is equal to 9, and we'll call that equation 2. So in this scenario here, none of the coefficients are equal to 1, so elimination really is the way to go. And I'm going to eliminate the b variable. So I'm going to multiply equation 1 by 3. Okay, and we'll get 12a minus 6b. And 14 times 3, we've got 30 plus 3 times 4 is 12, so 42. Okay, and then we'll do 2 times equation 2. Okay, so we have 18a plus 6b equals 9 times 2, 18. Okay, and since the signs are opposite here, I'm just going to add the 2 equations in order to eliminate the b variable. So 12a plus 18a. We've got 30a. The b expressions cancel each other out. And here we've got 42 plus 18 is 60. So a is equal to 60 divided by 3, which is 2. Okay, now I'm going to choose one of the equations in order to find the b variable. And I'm going to choose equation 1. Seems a little bit easier. So we'll put 4 times a, which is 2, minus 2b equals 14. Okay, bring the b to the other side. So here we have 8 minus 14 is negative 6. And so b is equal to negative 6 divided by 2, negative 3. And now we can give our final answer, since we have all the unknowns. Okay, so y is equal to ax squared, so 2x squared, plus bx, so minus 3x, and plus c, which in this case here is 4. Okay, there you have it. So again, what's important is to remember that in order to solve for more than one variable, you might need to set up a system of equations, and you want to choose the form of your quadratic equation carefully. Now say I had been given 3 points which didn't have anything special to them. They weren't an intercept, and they weren't related to the vertex. They were not symmetric points. Well, I could do exactly what I did here, just input all 3 points, and I would get a system of 3 equations and 3 unknowns, which of course we did solve earlier in the year. Okay, let's move on now to number 4, which is a factoring question, and a bit of an odd factoring question, but what you need to start to do is recognizing patterns. And when I take a look at this, the first thing I notice is that I've got a subtraction here, and I notice that this second one is a perfect square. Okay, so as soon as I see a subtraction of 2 expressions and one of them is a perfect square, the first thing that comes to mind is difference of squares. So the question is can I write this other term on the left as a perfect square? And I see a 25 x squared y to the 4th, and it looks like I can. Okay, so let's start by doing that. So this would be square root of 25 is 5, and then x squared, that'll just be x, and y to the 4th, that'll be y squared. And square that. So just check 25 x squared y to the 4th, and then minus x minus y squared. So I have a difference of squares. At this point here, we really just should know how to factor of difference of squares easily. So let's put in a general example. If I have something like a squared minus b squared, that factors as the first base plus the second base, okay, times the first base minus the second base. So I'm just going to apply that here. Okay, so we've got the first, which is 5xy squared plus x minus y, and then we've got the first 5xy squared minus the second x minus y. Okay, now notice here I put these in brackets, because when I look at my formula, it's a plus b, a minus b. I have to subtract the whole second expression, and so again I err on the side of caution. I always use brackets. It wouldn't have made a difference in this first part, but in this second part it definitely will make a difference. So I would expect you to simplify here. So here we've got 5xy squared, and the addition won't change anything in the bracket, so just plus x minus y. And here 5xy squared, and here it will change what's in the bracket. This is going to become minus x, and then negative 1 times negative 1 plus y. Okay. So again, we have to start recognizing these difference of squares, and the hints here are that we have a subtraction of 2 expressions, and one of them is clearly a perfect square. Okay, we'll take a look at a few more factoring questions in another video.